Good afternoon to you. This is Dr. Dinesh Syce, Professor of Physiology at SLIM Pondicherry. This afternoon, we spent half an hour to talk about the movements of the small intestine. So at the end of this little session, each and every last one of us should be able to describe the various movements of the small intestine. We should be aware of the purpose and function of each type of movement, and we should know of certain clinical conditions where these movements can be affected. Right? So that's the agenda for our little session this afternoon. So, small intestinal movements, you may wonder, why do these movements occur? What is the purpose of these movements? These movements essentially break the food down into small particles. And once the food is broken into small particles, the food particles are mixed with the intestinal juices. All this serves for better absorption of the nutrients from the intestine, right? So that's predominantly the function of these small intestinal movements. Now, before we begin with the various small intestinal movements, let us have a little recap about the innervation of the intestine, because all these movements, as you'll find out in a moment, are all predominantly, overwhelmingly controlled by the nervous system, by the various nerves, right? So if you recall, the intestine, the GIT, is supplied by two types of nerves. Yeah, you remember that? Can you name these two types of nerves? Yeah, you remember? The intrinsic and the extrinsic nerves. Do you remember? Yeah. So when we say the intrinsic nerves, we're talking about the nerves which are embedded, enmeshed in the walls of the small intestine. And what are these nerves otherwise called? They're called the enteric nervous system. Yeah. So the intrinsic nerves are the enteric nervous system. These are present within the walls of the small intestine, entrenched within the walls, right? So this enteric nervous system essentially consists of two networks of neurons. Do we remember the names? Yeah, it's the submucous and the myenteric plexus. Yeah, the submucous plexus and the myenteric plexus. Now the submucous plexus has another name beginning with the letter M. Do we remember? The Meissner's plexus. And the predominant function, the overwhelming function of Meissner's plexus is to control GI secretions. So Meissner's, over everything else, controls GI secretions. Okay? So what about the other plexus, the myenteric plexus? Does it have another name? It does, beginning with the letter A. Do you remember? It's called Auerbach's plexus. So if Meissner's controls the secretions, what do you think the myenteric plexus does? It controls the movements of the small intestine. Okay, so this is the enteric nervous system, the inbuilt nervous system present within the intestinal walls. It has two networks of neurons, myenteric and Meissner's, myenteric and the Meissner's plexus. Today, we're going to talk about predominantly myenteric plexus, which is responsible for the movements of the small intestine, right? So although the myenteric plexus controls small intestinal movements, its action is further augmented, further modified by the extrinsic nerves. Yeah, the nerves that come from outside. Can you name the extrinsic nerves? What are these otherwise called? They're called the autonomic nerves. Yeah, so the extrinsic nerves are the autonomic nerves, which can further modify the movements initiated by the myenteric plexus. Okay? So when we talk about the autonomic nervous system, we speak about predominantly the parasympathetic arm. Stimulation of the parasympathetic division involves increased intestinal motility, increased contraction of the small intestinal walls, and it causes relaxation of the sphincters. Okay? So before we even go to the movement of the small intestine, it's the nerves that control everything. There are two divisions of nerves, the intrinsic enteric nervous system and the extrinsic. So this is what they all do. Yeah? Now let's quickly proceed, begin with today's class, as it were. We're going to talk about the types of small intestinal movements. Today I'm going to talk to you about two fundamental types of small intestinal movements. The first is called propulsive movement. Propulsive. When we say propulsive, what does that mean? To push forward. So this type of movement will push foot forward along the small intestine. And the other type of movement is mixing movement. So essentially two types of movements play a role in the small intestine. One is propulsive and the other mixing, right? So when we talk about propulsive movements, as mentioned earlier, this is a type of movement which pushes foot forward along the small intestine into the large intestine. I'm going to give you two names, two types of propulsive movements pertaining to the small intestine. The first is called peristalsis, a word I'm sure you're already familiar with, peristalsis. And the other type of propulsive movements pertaining to the small intestine is probably a new term for you. It's called migratory motor complexes, MMC for short. Yeah, so migratory motor complexes and peristaltic movements, these are the two types of propulsive movements of the small intestine. Now we're going to come to the mixing movements. This movement, of course, as we know, mixes the food with the intestinal juices. There's only one type of small intestinal movement, small intestinal mixing movement. This is called segmentation. Okay, so essentially three types of movements we're going to deal with today. Peristalsis and migratory motor complexes, which are propulsive movements, segmentation, which is a mixing. In addition to this, we're going to just quickly, briefly mention in passing GI reflex involved with the small intestine, and this is the gastroileal reflex. Okay, and a reflex involving the stomach and the ileum. Right, so this is our agenda for this afternoon. Our plate is full, lots of things to discuss. Let us begin with propulsive movements. Right, so as mentioned earlier, propulsive movements push the foot forward along the small intestine, and the most important, the most well-known propulsive movement is peristalsis. So this is peristalsis. As you can see, this is a type of propulsive movement which pushes foot forward along the small intestine. So let's find out how peristalsis actually occurs. What happens when foot is being pushed, propelled forward down the small intestine? Yeah. So I hope you can see this is one stretch of small intestine from here to here. The green ball is partially digested food. Partially digested food. What do we call it? We call it chyme, right? So this chyme, it's in the presence, it looks like a ball, so it's called a bolus of chyme. So you have a bolus of chyme in the small intestinal lumen. So as you can see, this bolus of chyme is stretching out the intestinal walls. Because of that, two things happen. Yeah. So the bolus of chyme stretches out the small intestinal walls. Because of that, two things happen. First of all, the segment of intestine behind the bolus of chyme, this is the segment behind the bolus of chyme. This segment, can you see what happens? It contracts. Okay, so the segment behind the bolus of chyme, this segment over here contracts. There's another segment involved. The segment in front of the bolus of chyme, this one over here. What happens to that? This one, can you guess? This one relaxes. Yeah. So one more time. We have a bolus of chyme, partially digested food in the intestinal lumen, which is stretching out the intestinal walls. In response to this, two things happen. The segment behind the bolus will contract. The segment in front will relax. Because of this, food is going to be pushed slightly forward, just a few inches forward down the intestine, like so. Okay, the food was here, now it's being pushed just a little bit forward. Right? So what's going to happen next? The same thing will happen over and over again. Another segment behind the bolus of chyme will contract. Segment in front will relax. The foot will be pushed down just a little bit forward. Right? As you can see, the foot is pushed down just a little bit forward. And this keeps happening over and over again, inch by inch. The bolus of chyme will be pushed down the entire stretch of the small intestine into the colon. Yeah, so this is peristalsis. So this is the propulsive movement of the small intestine, which pushes food forward down the intestinal lumen. How does it happen? Two segments are involved. The segment behind will contract, the segment in front will relax, pushing food forward just a little bit. This happens over and over again. Right. Now, let's find out what are the neurotransmitters which are responsible for the contraction of the wall and the relaxation of the wall, right? So one neurotransmitter, the most predominant one, which is responsible for the contraction of the segment of the intestine is, any guesses? Acetylcholine. It's acetylcholine. This is the most important neurotransmitter, which causes contraction of the segment, right? And the segment in front relaxes. We've just dealt with that. So which is the neurotransmitter responsible for that? Can you think of any relaxing neurotransmitter beginning with the letter N? Nitric oxide, right? Most importantly, nitric oxide and VIP. Okay, so this is peristalsis. The propulsive movement of food down the small intestine. There's a contraction of one segment, relaxation of the other segment. These are the neurotransmitters involved. Right. Now, what is the direction of the movement of the kite? In which direction is it going to move? So the movement of the kite predominantly is in the aboral direction. Aborally. What does that mean? From the oral end to the opposite end. Okay, so from the mouth to the opposite end, this is the direction, the predominant, overwhelming direction of peristalsis, right? From the oral to the aboral end. What is this called? This is called the law of the small intestine or the law of the gut. So when we say food is going to be propelled from the oral to the aboral end, this is called the law of the gut, the law of the intestine. Yeah, so this is peristalsis. As mentioned earlier, in our first slide together, this is controlled predominantly by the enteric nervous system. Its function can be modified by the parasympathetic nerves. Yeah, and the function is to push food forward down the small intestine into the large intestine. Yeah, so as mentioned earlier, although the direction of peristalsis is predominantly aborally from the oral to the aboral end, it can happen in the opposite direction as well. This is called reverse peristalsis. Peristalsis in the opposite direction. As you can see from the picture, this happens predominantly in vomiting. So in vomiting, the movement of food is from the intestine to the stomach, from the stomach to the esophagus, and outside the body, right? So reverse peristalsis is peristalsis in the opposite direction, occurs predominantly during vomiting. Fine. So we dealt with one most very important propulsive movement, peristalsis. Now we're going to talk about another propulsive movement, this one over here. So as you can see, on our screen, we have an adorable little child. What is she doing over here? She is sweeping the crumbs from the floor. Yeah, can you see that? Now we're going to talk about a type of intestinal movement which does precisely this. It's called migratory motor complexes, MMC for short. So migratory motor complexes are propulsive movements which does this. Okay, so we'll find out what that is in just a moment, right? So what are migratory motor complexes? These are propulsive movements which begin in the stomach and they go down the entire small intestine. When do these movements occur? Do they occur when we're having a meal? No, they occur between meals in the interdigestive phase. So the migratory motor complexes are propulsive movements which occur in the interdigestive phase in the period between two meals, right? So they happen every hour and a half. So now here in Pondicherry this morning, it's about 12:30. So most of our students have gone for lunch now. So let us assume we're having lunch at 12:30. What happens to the food? Food goes into the stomach. It's broken down to the stomach. In the stomach, it's partially digested in the stomach, pushed into the small intestine, digested further in the intestine, pushed down the intestine by peristalsis. Right? But not all the food will be pushed out through the intestine. Certain morsels of food, certain particles of food will be sticking on to the walls of the small intestine even after the meal. So about 2 hours after the meal, what's going to happen? These migratory motor complexes will start in the stomach, go down the small intestine, and their job is to take away, remove these particles of food which are sticking on to the small intestinal walls. Yeah? So the migratory motor complexes begin about an hour and a half after a meal. What do? They sweep away, they clean away the particles of food from the previous meal, which are still sticking on to the walls of the intestine. Why why does this occur? What is the purpose of these movements? To clean away the intestine, to keep the intestine clean and ready to accept the next meal. Okay, so what are these movements otherwise called? They have a colorful name. They're called the housekeepers of the small intestine. Why? Because they do precisely what, very similar to what a housekeeper does, cleaning away, sweeping away the little particles from the small intestine. Now, these migratory motor complexes are augmented, they are increased by a hormone called motility. Yeah, you've probably heard of motility from GI hormones. Motility augments migratory motor complexes, right? So we've dealt with the propulsive movements, peristalsis and migratory motor complexes. Now we go to another type of movement. If you recall, we're going to talk about the mixing movements now. Now, let me ask you to look at your screen over here. You see a stretch of small intestine. Now, is this a smooth stretch of intestine? No, it's not. As you can see, the intestine is broken down into lots of segments. Fine. So the name of this movement is segmentation. One thing is out of the way. The name is segmentation, right? Why? Because the intestine is broken down into segments. Right? Now, what is the purpose of segmentation? May I ask you to look at this segment over here? You can see brown colored chyme, and the neighboring segment has blue colored chyme, right? In the next picture, look what happens. The brown and the blue are mixed together in a single segment. So what do you think this type of movement segmentation does? It mixes the food together. This is a mixing movement. So now we're going to talk about the mixing movements, and it's called segmentation. Why is it called segmentation? Because the intestine is thrown into lots of little segments, right? So again, let's go to this is a stretch of small intestine. As you can see, there are rings of contraction at regular intervals. One ring of contraction here, another here, another here, another here. Because of this, the entire stretch of intestine is broken down into alternate contracted and relaxed segment. This is a contracted segment. The neighboring segment is relaxed. The neighboring segment is contracted. The neighboring segment is relaxed again. Okay, so they're alternate, contracted, and relaxed segments. Right? Now, let me ask you to train your eyes on this particular segment. We'll call it segment A. At this point in time, segment A is contracted. Just next door to segment A, you see another segment over here. What do you think it is? Do you think it's relaxed or contracted? This segment B, we'll call it, is at this point of time relaxed. Okay, so segment A right now is contracted. The neighboring segment B is relaxed at this point of time. Because of this, food is going to be pushed, time is going to be pushed from A to B in this direction. Okay, so one more time. We have a segment A, which is contracted at this point of time. Right now, the neighboring segment B is relaxed because of this. At this point of time, food is pushed from A to B. You'll notice that I keep saying at this point of time because in just a moment, everything will change. Right? So what happens next? Just the opposite happens in just a few moments. Now, B will contract. As you can see, B is now contracted, and A, as you can notice, is now relaxed. So B now contracts and A relaxes. So where do you think food is going to be pushed? From B to A in the opposite direction. So initially food was pushed from A to B in this direction. Now food is being pushed in the opposite direction. So this keeps happening over and over again, back and forth movement of food without any net forward movement of food. This is called segmentation. Okay, so can you tell me, What purpose does it serve? So as we mentioned earlier, it mixes the food. Yes, it mixes the food with the small intestinal juices, number one, most importantly, and it breaks the food down into very small particles. Thorough mixing and breaking down of food. Yeah, that's quite obvious. Can you tell me any other function this type of movement has? Yeah, can you think about it? Food is not moving forward, it's staying in place. So there's more time for the absorption of nutrients. So this type of movement helps in the absorption of nutrients as well. Right? So this was segmentation, the mixing movements of the small intestine. Now let's quickly go through, in passing, we'll talk about one motility reflex, which involves the stomach and the ileum. This is called the gastroileal reflex. Gastro refers to stomach. Ileum is the ileum, the terminal portion of the small intestine. So what happens during this reflex? When we have a meal, the stomach is distended with food. In response to that, reflexly, almost immediately, there is increased peristaltic movement of the terminal ileum. Okay, so when we have a meal, the stomach is distended. Reflexly, the terminal ileum shows increased motility, and one more thing happens. The ileocecal valve will also relax. Because of this, food is now pushed from the small intestine into the cecum, into the colon. Yeah, so that's the gastroileal flex. So since we are, our time is running out, let's quickly go through just one applied aspect pertaining to movements of the small intestine, and it's called adynamic ileus. Yeah, as I always say, it's all in the name. Everything is in the name. Ileus refers to the ileum, adynamic. I hope you know what dynamic means. Dynamic means very active. So, but when you put an A in front of that, it means just the opposite. It means sluggish, lazy, slow. So we're going to talk about a condition where there's slow movements of the ileum. All right, the movements of the ileum are very sluggish, very slow. There is almost a paralysis of the ileum, so it's otherwise called paralytic ileus. Yeah, so paralytic or adynamic ileus is a condition where there's very slow movement of the small intestine. Because of this, the small intestinal contents are not pushed forward. Because of this, the small intestinal contents are retained in the small intestine. Because of this, the small intestine is distended. Okay, the intestine is distended with fluid and gas. So this is called adynamic or paralytic ileus, where there's decreased sluggish movements of the small intestine. Because of this, the small intestinal contents are retained in the lumen of the small intestine, causing distension of the small intestine. Yeah. So when can this occur? When can you come across this condition in your clinical practice? It happens very commonly after abdominal surgery. So during abdominal surgery, if you've ever seen an abdominal surgery, the surgeon will reach his hand into the abdominal cavity, pull out loop after loop of intestine, and once the surgery is done, he'll put back the loops of intestine. So because of this excessive handling of the intestine, after surgery, the intestinal movements may be sluggish for just a little while, maybe a day or so, or even longer. So this is called paralytic ileus. Yeah. So another condition, another situation where paralytic ileus can occur is peritonitis. So what's peritonitis? We know the peritoneum, the lining of the abdominal cavity. So peritonitis is an inflammation of this peritoneum, right? And for some reason, it's very often seen that paralytic ileus is associated with hypokalemia. Hypokalemia means decreased potassium level in the blood. Okay, so with this, because our time has run out, we're going to stop with today's lecture. Today, if you recall, we spoke about the various types of movements of the small intestine, the propulsive movements, peristalsis and migratory motor complexes, and the mixing movements, segmentation. We also spoke about a clinical situation, paralytic ileus or adynamic ileus. Okay, so thank you very much for your attention. I think we'll stop this lecture here.